Hey, I have taken a giant break between this video and the last one. And my goal tonight is 2 videos because I really have nothing else on except I'm keeping my fingers crossed that there's some sort of hockey game on TV. This is, I like this stuff. I probably say that a lot, but then I really like calculus. Again, not more than hockey. This is called logarithmic differentiation, and I know it says logarithms, and I know some of you really don't like logarithms, but this really is a good thing because you use this in 2 situations. The first situation you use it in is when you have a power with a variable exponent, so that means a letter exponent. The second, usually you have a number exponent. So for instance, usually you have something like this where that is a number. But I'm talking about when you have something like that, where that is a variable. So that's one place you use logarithmic differentiation. The second place you use logarithmic differentiation, and I quite like this, is when you have super messy product rule questions or super messy quotient rule questions or super messy combo questions between the product and the quotient rule that you just don't feel like doing. Because it would take you pages and pages. So I'm going to give you an example of that. I assume my example is beneath here. Oh, there's 2. There's 2 of this situation. Situation A. And then if I flip the page, boom, there is a combo question of product rule and quotient rule. And of course, you can do this by product rule and quotient rule, only it's terrible. So I'm going to go back to this and I'm going to run through the steps. And if I remember, I will come back to these steps every single time. But this is the steps for logarithmic differentiation. So the first thing you do is realize that logarithms are like this, where it could be a base 10. Its logarithms are like this, where it could be a base anything else. And you also have logarithms with a base e. And when that's the case, that is equal to ln. So the first step specifically is to take the ln, the natural logarithm of both sides. And I'll show you why in a minute. The next thing you do, and this is the part that should scare you, especially if you don't remember your logarithm rules, which you could go over using any of the stuff that I put on the Google site. You could go back to the advanced functions section. You split the right-hand side, so that is this side, or it's this side. You split the right-hand side using log or ln rules. They are the same, so I can say that. Then you take the derivative of both sides, and this is actually a place where people screw up because it's so easy. And then you multiply both sides by y to solve for dy by dx, and we'll see how that works in a second. So I'm going to dig out an alternate color to black, which is what y is, and I am going to take exactly the same as I've written here. I'm going to take the ln of both sides. So I'm going to use red temporarily. So I've got ln, back to black, of y equals ln of 3 to the x. And I've already botched my color coding. So if you put the natural logarithm on one side versus the other, you are wrong. It is take the ln of both sides. So if you don't do the same thing to both sides of the equal sign, you have unbalanced this equation. The next thing you want to do is you want to use the law of powers that you are allowed to use with logarithms. And you're allowed to use them with natural logarithms. And the law of powers says that anytime you have an exponent that is in the air, whether it's number or letter, it can shove down in front. And this has nothing to do with derivatives. This is just a rule of logarithms. And then I'm going to actually change colors semi-permanently, and we're going to take the derivative of that. Now, it says take the derivative of both sides, and you know what the derivative of ln is because I've taught you that. So it's 1 over what you're lning times by the derivative of that, which is y, but it's a y. So just like implicit differentiation, you need a y prime, or I like to make a big deal about it, so I call it dy by dx. Then, on this side, you can do one of two things. You can pretend like this is a product rule, which I don't advise, but I'll show you in a second why I don't advise it, because I'm going to do it anyhow. Derivative of the front multiplied by the back, plus for product rule. The derivative of the back has no x's. Ln 3 is just a really fancy looking number, and the derivative of a number is 0 times the front, which is an x. Now, it doesn't really matter what you put there because 0 times anything is 0, so the next line for me, and I have no idea why this changed color, so let me be consistent. The next line for me would be 1 over y times 1, which is 1 over y, dy by dx, equals 1 times ln 3 is ln 3, plus 0, and I'm not going to write that. So really what you can do is you can not do the product rule here because both pieces do not contain an x, and you can take the derivative of x ln 3 and say, oh, that's just a number attached to x, so it's just the number. But this is a very safe way to do it, assuming you don't come up with some crazy answer for the derivative of ln 3, which is always going to be 0. The problem with this answer, which is us doing it up to step 3, is that we don't have dy by dx by itself. So what we have to do on both sides of the equal sign, because we have to keep things balanced, is we have to multiply by y. Which is step 4. And what that means is that this y, which is a numerator, and this y, which is a denominator, cancel out. I can dig back out my blue pen, write just the dy by dx, and then instead of y, I'm going to go back up to the question and check what y used to be, which is 3 to the exponent x. So I'm going to say ln 3 in a bracket to keep it separate, times y, which is 3 to the x. The end. Let's do that again. So here we have situation A, a power with a variable exponent. It's actually a super ugly variable exponent, but it's still a variable exponent. So step 1, take the ln of both sides. So ln of y, ln of 2 to the x squared plus 2x. So I'm going to go back and put my originals in here. Notice you have to put ln on both sides. That's part of the instructions. Then you have to take the exponent down in front. That is the split the right-hand side using the log/ln rules. So this side's going to stay the same. Don't do anything to it as far as derivatives go. You can't do the derivative of one side and not do the other. So we're still in the process of making this look able to be taken the derivative of. So there's my numerator, or there's my exponent going down in front using the law of powers, wrapped in a bracket because it's a binomial, and ln 2 behind it. So now I can dig out my blue pen again. And there is a pattern to this, as in every single time you take the ln of y, you get this, which brings you to this. So if you want to take a little shortcut, that is the derivative of the left-hand side. Again, you can do this using the product rule. So the derivative of the front is, in a bracket, 2x plus 2 multiplied by the back, plus the derivative of the back, which has no x, so it's a 0, times the front, which I'm not going to waste my handwriting with. So next step is I am going to multiply both sides by y. So multiply this by y to cancel them out, multiply this by y to balance. So in blue, on the left, just dy by dx. In blue, on the right, 2x plus 2 times ln 2, no 0, and then we're multiplying by y. And some books will have that written in it. I am going to go one step further, just because And I'm going to go retrieve my y from the original question, which was 2 to the x squared plus 2x. Now I want to show you some crazy math that you can do, because remember what I told you, hopefully many times, is that you can keep going with a lot of math that you probably don't think of, but the people who write textbooks think of it. So one of the things that you could do is you could take this bracket and common factor out a 2. Why? Because you can. And then that 2 is actually a 2 to the 1, and all this is being multiplied together. So we've got a bracket of x plus 1, a bracket of ln 2, I'm going to take out the dot, and a bracket of 2 to the x squared plus 2x, and when you're multiplying with the same base, you add exponents, so you could do that. And these are all OR answers. But you may see this in the back of the book and go, how the heck am I supposed to know how to do that? And the answer is, you just keep doing math. So you also should be able to take this answer and backtrack and see, oh, do I have anything like it? And that is one of the struggles with calculus. So let's take a look at the other case where you take the logarithmic differentiation or the logarithmic derivatives. So I've got two questions. Here's the one I showed you, and then, whoa, that guy. So this question, a little bit different, except we start exactly the same. So these blue rules are exactly the same. Take the natural logarithm of both sides, split the right-hand side using log or ln rules. I'll come back to step 3 in a second. So, red pen. Ln. Original was y here. Original was x plus 1 squared times 3x minus 2 all over, and just for kicks, I'm going to remind you that a square root is the same thing as an exponent 1/2. And technically, I guess I should put all that in a bracket to say, I am learning all of that. So, next step. This left-hand side is usually fairly untouchable, meaning you don't need to. This side, not so much. So you are lawning, bad math terminology, but you are lawning these three things that are products and quotients. And you have an old advanced functions law of addition / multiplication and law of subtraction / division. So I'm going to do this in 2 steps, even though I would normally, with an audience, do it in 1. I'm going to take the ln of x plus 1 squared, and because that's multiplied, that changes to the law of addition. The ln of that chunk of information, so 3x minus 2, and then I'm dividing, so law of division / subtraction, ln, don't lose that, of x squared plus 2x minus 5 to the 1/2. And I have not taken any derivatives yet. Notice I am still with the black pen and not with the blue. And that looks a heck of a lot better to me, because it's not multi-leveled. It is now one line of work. Now I can do one more thing, and that is wherever there's a power, I can use my law of powers to drop that down. So that means I've eliminated the chain rule or the power rule or the outside inside, whatever you want to call it. So this one, the 2 can float down, not derivatives. This one, don't need to do anything. This one, 1/2, don't lose the ln. I was about to not write that down, and you absolutely must have it there. So if it's a 3-part question, 1, 2, 3, you need 3 lns. Technically 4, 1 on the other side. So now I'm good to go with my blue pen. I've stretched it out using my logarithmic rules. That is part 2. We have eliminated the messy product quotient rule question. We now have to take the derivative of both sides. So derivative of the left. 1 over what you're lawning times 1, which is the derivative of y, times dy by dx. This 2 stays put. Derivative of ln is 1 over what you're lawning times by the derivative of that. Plus 1 over what you're lawning. Very bad math language. Don't change your pluses to minuses or your minuses to plus. Times by the derivative of it. Minus 1/2. 1 over what you're lawning. Times by the derivative of that, the operator. Don't make a mistake. Throws everything off and makes it difficult for me to mark. And it's all about me. So now I'm going to clean this up. Don't worry, you are not going to have to do that 1, 2, 3 thing to get yourself a common denominator. So don't get all panicky on me yet. But I do have to clean up those 3 sections. It's going to take me a bit of work. Remember, these are all 1s. This is a 1. This is a 1. So in this section between the equals and the plus sign, I've got 2 times 1 times 1 over 1 times x plus 1 times 1 plus 1 times 3 over 3x minus 2 times 1 minus sign 1 times 2x plus 2, which just for fun, because I can, I'm going to common factor out, over 2 times this times 1, which is this. Can you see why I common factored now? So I'm going to cross out this 2 with this 2. Do not cross out this 3 with this 3. That is a totally different situation. This 2 is multiplied by this bracket. This 2 is multiplied by this bracket. This 3 is not being multiplied by a bracket. It's being multiplied by an x, and then you've got minus blah, 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 or plus blah, blah, blah. You can't do that. So get that idea out of your brain and just cross out these ones. So I'm going to do a 2 for 1 line. I am going to rewrite all of this without my slashed out 2's. Oh, I've got a hand cramp happening. And then I'm going to wrap it all in a bracket to say, I was here first. I'm going to say now that I'm going to multiply this side by y, so they cancel, and I'm going to multiply this side by y. Technically, if I do that, I should put this in a big bracket. That means on the left, I have dy by dx, and on the right, I have this times y, or if you prefer, times the original version of y. And I'm going to put it back to the root because I've got nobody to impress with my answer. And there's no crossing out here either. So this scoots down. Here. And technically, I should be putting this in a bracket to say all of this. Now, if you didn't have this here, so let's say you had this, I'm going to take off a mark because that's not the answer. However, if you decided to be all lazy and just do that, I'm okay with that. However, you may see in an answer key somewhere this big lot of information that you're going to wonder where it came from, and it's likely just the original version of y. So we did 2 examples of a power with a variable exponent there. So let's do 2 examples of messy product quotient rule questions. So there was our 1 right there. Let's do a final one here. And oh my gosh, I've given you a value. What are we going to do with that? So This is a combo of product and quotient rule. And I don't want to do a combo of product and quotient rule, which is why logarithmic differentiation is awesome. So I'm going to take the ln of both sides. The reason we don't take the log of both sides is because the derivative is far worse. So we take the ln because you know the derivative. It's 1 over what you're lning times by the derivative of what you're lning. So you're lning that whole thing, which is why I put the square brackets there. So next line, ln y equals, let's stretch this out. We have to be super careful about this. The one thing I'm excited about is there's no exponents, so that means there's no law of powers that I have to worry about. But I do have to worry about ln of 5x plus 1. I have to worry about ln of 2x minus 7. I have to worry about the ln of 3x minus 5. Again, no exponents to worry about. And I have to worry about the ln of x plus 3. And this is multiply. So between those two pieces, I have a plus. Then I'm dividing by this. But I am also dividing by this. I know these two things are times together, but this quantity is being divided by x plus 3. So I need that as a minus sign. No law of powers, which some of you are going to be able to handle stretching out and dropping down at the same time. And you're going to be very good at realizing that we haven't taken a derivative yet. When you drop down for the law of powers, that looks like the derivative, but it's not. We are now about to take the derivative. Drum roll if you like. 1 over y dy by dx. If you want a 1 in there, you totally can. Equals 1 over 5x plus 1 times 5, 1 over what you're lning times the derivative of it, plus 1 over 2x minus 7 times 2, minus 1 over 3x minus 5 times 3, minus 1 over x plus 3 times 1. Now you can do a little cleanup job here if you like, or you can clean up and you can insert an x equals 0 in. So I am actually going to do that. So we'll leave it there and hope I can squash it in. So on the left-hand side, I'm leaving it alone. So this is 1. Actually, let me put my 1s down. One times 5 is 5 over 5 times x is 0 plus 1 plus 1 times 2 is 2. 2 times 0 minus 7 minus 1 times 3. 3 over 3 times 0 minus 5 minus 1 times 1 over 0 plus 3. Let's tidy this up. Oh, I might need a little hand stretch. So this one's 5 over 0 plus 1, so this is 5, plus 2 over negative 7, minus 3 over negative 5, minus 1 over 3. So if you want to, you can go absolutely crazy and get yourself common denominator. If you don't want to, that's also okay. You could use your ABC button, assuming you have it. So I'd be doing 5 minus 2 over 7 plus 3 over 5 minus 1. Now, notice I lost the 1 over y, so I'm going to have to multiply by y. So before I just put a bracket around this and dump a y here like usual, I'm not going to dump a y there. I am going to go back up to the original question And I am going to put x is 0 in here, so I have a number value for y. So y is equal to 5 times 0 plus 1 times 2 times 0 minus 7 over 3 times 0 minus 5 times 0 plus 3. So that ends up being 1 times negative 7 times negative 5 times 3. So that's negative 7 over negative 15, which is 7 over 15. So that's my y value. So I'm going to go downstairs, and instead of putting that dot y, I'm going to put, oh, I've forgotten what it is already, 7 over 15. Now I'm going to impress you with my fraction abilities. So 7 and 5 is 35 times 3 is 105. So my common denominator for this is 105. So 105, 105, 105, 105. So 5 times 105 is, I hope, 525. This would be 7 times the 5 and the 3, so that'd be 2 times the 5 and the 3. So that's 2 times 15, which is 30. This 5 times by the 7 and the 3, so this 3 times by the 7 and the 3. And then finally, this 3 gets times by the 7 and the 5, so this 1 gets times by the 7 and the 5. So we get that. So I have 525 minus 65. That's this one and this one. Oh, but I'm going to add 63, so that's actually 525 minus 2. So this whole bracket will be 523 over 105 was my common denominator. Your ABC button should tell you exactly the same thing. Gosh, I hope. I don't have mine handy. So I hope to not be embarrassing myself. And then that is going to wrap in a bracket because we still have to multiply that by 7 over 15. So that's I think that for dy by dx, which, a reminder, that is the slope of the tangent. So the slope of the tangent is a very ugly rise over run. But we know it's an uphill slope of the tangent. So, sorry if my calculations are wrong. I am pretending that I'm at a school that doesn't let me use a calculator. However, I certainly would have been more careful because I know some of you are uninterested in being impressed by me. I like to impress people. Anyhow, out of that textbook, I didn't think they did a great job, so I've given you a sheet A and sheet B. They should be on the Google site, so that is it. And now I've got my mojo going, and I'll do one more logarithmic note. It probably is something that I would in class do ahead of time. So anyhow, let's see how that goes. Oh my gosh, I'm beating records.